So good afternoon everybody, myself Acharya Vishvendra. Let's discuss fluid mechanics today. So the first thing is a substance which can flow are called fluids, and they includes liquids and gases, and they have the property that they cannot bear shear stress or tangential stress. If you apply tangential stress to a fluid, it will move in the direction of stress, and until that stress becomes zero, it will keep on moving. So under a static condition, tangential stress on that is zero. We'll use this property further. Now let's discuss the concept of pressure. Suppose there is a liquid and it is filled in a container up to height h. Consider a certain sphere inside this. So this sphere is enacted upon by forces from the liquid itself in various directions. So if we divide force by area, that is called the pressure. So there are certain points regarding pressure. First is it's a scalar quantity. Its dimension is m1 L minus 1 T minus 2. SI unit is Newton per meter square, which is also called Pascal. CGS unit is Dan per centimeter square. Certain other units are Pascal, ATM, bar, mmHg, cmHg, and torr. Then there are certain relations between these parameters. These relations are that 1 bar is equal to 1 into 10 is to power 5 Newton per meter square. 1 ATM is 1.01 10 is to power 5 Newton per meter square. 1 ATM is 76 centimeter of Hg, 760 torr of Hg, or 760 mm of Hg. And out of these units, ATM is the largest unit of pressure. Now let's derive the expression of pressure at a certain depth in a liquid. So for that, consider a liquid, and we need to calculate pressure at a depth h from the free surface. So for that, consider this cylinder. So on the cylinder, from the top, air is pulling it down, so there will be force downward in this direction. There will be certain weight of this particular cylinder which is acting downward. So if it is rest, then it's a common sense thing that the force from the liquid below the surface will be in vertically upward direction. Now at equilibrium position, net force should be 0. So that means Fb is equal to Fa plus mg. Now pressure is force by area, so force will be pressure into area. So at point B, force will be Pb into A, PA plus dAgh. So from this expression, Pb is equal to Pa plus dHg. If h is equals to 0, Pa is equals to Pb. If you draw the graph will be a straight line corresponding to this, and the angle theta comes out to be dgh by h, or it is equal to dg. Here Pb is called the absolute pressure, and Pb minus Pa is called the gauge pressure as per the terminologies are concerned. Now let's solve a numerical based on this. So suppose a liquid of density is given. We need to find, the first thing is pressure at A. So obviously A is open to the atmosphere, so pressure will be equal there. So it is 10 is to power 5 Newton per meter square approximately. Pressure at B, P naught plus dgh. So if we calculate, it comes out to be this much. Pressure at C, P naught plus dgh. Calculations, after calculation, it will be equal to this. Now there is another question that if a small sphere of side is placed, find force on it. So we know that force is pressure into area. So by multiplying with pressure, you can find forces corresponding to the different points on this. Then there is another algebraic type of question. There are two liquids, densities d1, d2, heights h1, h2. We need to find at different points. So pressure at A is going to be P naught. Then pressure at B is going to be P naught plus T1 GH1. Now pressure at C is going to be Pb plus D2 GH2. So after calculations, we can find the pressure at the 3 points. Then there is another question, same, we need to find a pressure at point ABC. So first question is pressure at A, it will be atmospheric pressure. Pressure at B, P naught plus dgh. Pressure at C, so P naught Pb plus 2d g into 2h. So it will be this. Pressure at D we can calculate. Then another question is SI unit of pressure, it is Pascal or Newton per meter square. Then CGS unit, it is Dan per centimeter square. Dimensional formula m1 L minus 1 T minus 2. Different unit of pressure, we know Pascal, ATM, torr, bar, mmHg, cmHg, etc. Largest unit among these is ATM, as we have calculated earlier. Now there is another question of equivalent liquid. So for that, just assume that there is a single liquid of having density D equivalent. So just equal the pressure in the two cases. Suppose there is a single liquid of density D equivalent and having a height of 6h. So pressure here will be Pa plus D equivalent G into 6h, and pressure here will be Pa plus 14dH. Using this, D equivalent comes out to be 7D by 3. Next is a question on rotating tube. So tube is rotated, and in a tube there is a certain liquid fully filled and it is rotated about the end. So we need to find which end will be at high pressure. So let's understand the mechanics of this. So certainly we can say that if it is rotating with an angular velocity omega, then certainly let us consider a point A inside the liquid. There has to be a net force toward the center. So if there is a net force toward the center, that means the external point's pressure should be greater than the internal point pressure. So we can say that P2 greater than P1. So the outer ends will be at high pressure. So the point Q will be at high pressure. Then we need to find pressure difference and the graphical variation. So let's proceed with things in proper perspectives. So let's assume that there is a element of length dx and this element is moving. So if we consider pressure on the left as P dash and on the right as P double dash, I take it as P plus dP. So the net force will be dP into A, and the concept here is that this net force will provide the centripetal force necessary for the rotation of the elemental part. So the centripetal force is mr omega square. Now mass can be written as density into volume. Volume can be written as area into length. So from this we get the expression for the elemental change in pressure as this. Now we integrate this from P1 to P2, and after integration the result comes out to be PQ minus P is equal to d omega square L square by 2. So we can mathematically prove that pressure at Q is greater than pressure at P. Now see the graphical variation. So the first question is graph with D, straight line. Graph with omega, parabola it is proportional to omega square. Graph with omega square, again straight line. Graph with L, again L square is there, so graph will be parabola. Now there is another question based on this. We need to find it's rotated about the angular bisector. So the first question is pressure difference, pressure at A and B. So we can say that PA minus PC using the same concept. Here length will be L by 2. So external point pressure is greater than internal point by this much. So we can find from here PA and PC, as PC is given to be 0. So using this we can say that both P and PB will be equal. So PA will be this and this will be PB also. So pressure difference will be 0 between A and B. Similarly, if we check the length as L by 3 into L by 3, we can similarly calculate this question. Now there is another question that if the road is made horizontal, so here we'll use the concept of fluid that tangential stress is 0. So the tangential forces will be 0. So obviously if we move the container to the right, then the liquid will move to the left so as to be in a certain shape such that tangential force is 0 on it. So suppose it makes an angle theta with the horizontal, then this is the surface and this is the normal. So along the surface we have forces as ma cos theta and mg cos 90 minus theta. Equating these we get the expression that A is equal to g tan theta, or tan theta is equal to A by g. So theta comes out to be tan inverse of A by g. Then there are certain questions on that. Here theta we have to find if A is g. So calculating that you can calculate theta for different cases. So in this way you can solve your questions efficiently. Thank you and have a nice day.